Oh, all right, our next speaker is Dr. Leonie Jacobs, and since I didn't do the biography or background information on Dr. Bopek, I'll let Leonie take the floor.
All right. This is going to be try not to make too many sounds with my clothing. So yeah, that's right. At least nature is quiet now. So thank you so much for having me. I'm really excited to share some of the research that we've been doing around broiler chicken enrichments and a focus on affective states. So today, just going to get this out of the way a little bit. Now it is, yeah. So today I'm going to give a quick summary about why environmental enrichments matter in general and why they matter for broiler chickens. I'll give you a little bit of a theoretical background on affective states and how to measure affective states. So you'll feel a little bit like you're back in the classroom, getting some theory. And then I'll like to share some research that we have done in our lab, focusing on enrichments and stocking density for fast-growing broilers and enrichments for a fast and slow-growing strain. And then I just have one slide with some future research directions where I think the work should be going. So why do environmental enrichments matter? I don't know, maybe most of you do know, but these items in the environment for broiler chickens or any animals really provide animals with an opportunity to choose what they do. And choice is very important for animal welfare. So providing these variety and complexity in their environment will give them the opportunity to explore or eat or rest. They can choose, and that improves their welfare outcomes and their quality of life. So this video is an example of some of the enrichments that we've used in our experiments. They really love those sort of hay balls, and they also like cabbage, especially if they're a little older. So environmental enrichments can benefit the sort of main three aspects of animal welfare, and that includes health. So we've seen benefits of providing these enrichments on health outcomes, and I'll give a list and a short summary of some of those. We see an impact on animal behavior, probably the most direct association, right? So you give them an item, they interact with that item, they show more positive behaviors. In the case of broiler chickens, that would be increased activity, perhaps foraging, exploration. And it can impact affective state and emotion. And that's what we're going to talk about today. Sorry, I feel like I'm really loud, but so we'll focus mostly on affective states today, but I do want to give a summary of the health and behavior benefits that have been found in other research. So most of these benefits of environmental enrichment have been reported for fast-growing broilers, and that makes sense. These are the main type of birds that are being produced. But there is a slowly growing body of research showing impacts of environmental enrichments on the slower growing strains too. So first, let's look at health. So a lot of research has focused on leg health for broiler chickens, mostly because this is a big risk for animal welfare, especially for broilers. So providing environmental enrichments, and in this case, this could be platforms with ramps or without ramps, providing peat or some type of dust bathing material, providing straw bales or hay bales, or a combination of those things, have resulted in improved walking ability, so reduced lameness, reduced footbed dermatitis, so those lesions on their feet, reduced hock burns, and improved tibial characteristics. So we can really see benefits here. Then there was one other study that used a very complex environment and saw some other benefits too. So they saw a reduced incidence of scratches on the carcasses, reduced on-farm mortality, and reduced rejections at the processing plant. So these are some really nice results from just providing a more complex environment. However, the outcomes of research are not always positive or consistent. Unfortunately, there's Also a range of studies out there that either show negative effects. So for instance, reduced feather cleanliness when they are provided with platforms, probably because the fecal matter that the birds underneath can be exposed to. There's studies that have found no benefit on footpad health or leg health. So sometimes it just doesn't help their welfare. And there was one study that reported reduced walking ability when birds were exposed to a complex environment, although the authors do argue that walking ability in both treatment groups was good, but it was just a little worsened in the complex. So I'm not going to tell you that everything is better when you provide them with environmental enrichments. In some cases, it doesn't benefit health outcomes. And yeah, that's also something that we have to deal with and maybe figure out why in those cases it didn't benefit it. So when we look at the benefits of enrichments on behavior, we want to stimulate those natural behaviors and maybe want to avoid some negative behaviors, which for broiler chickens is mostly inactivity. And that's deemed negative because it's associated with some health issues like the contact dermatitis. So if you provide them with platforms, we give them the opportunity to to rest on an elevated space. So that's like perching for chickens, but also have undisturbed resting underneath. So rather than just resting near the feeder or the waterer, they have an opportunity to go somewhere where they're not as disturbed as much by other birds. Studies show that if you provide them hay bales or straw bales, birds will show more explorative behavior. So this could be pecking at the straw bales, more foraging around the straw bales, so more activity and a natural behavior, which is important to stimulate. When you provide broilers with a highly complex environment, meaning a range of enrichment, not just only straw bales or only platforms, we see more foraging. So that's that searching for food type behavior, which is also deemed positive. We see more locomotion and foraging when birds are fed with live insects, although some studies are now showing that that is very temporary. So it's not throughout the life, but maybe just when you provide them with the insects, the activity increases at that point, but reduces quickly thereafter. And then we see a general increase in activity when broilers are housed with colored balls and a mirror, when they are housed with platforms, bales, and laser projections, or purchased dust baths and temporary enrichment. So we really see a direct benefit of these enrichments on their behavior. So as I said, today we're going to talk more about affective states, and because this is maybe a more complex aspect, I just want to put a definition out there. So affective states are long-term moods or emotional states that result from accumulation of experiences. So it's not how you feel in response to one specific thing that happened to you, but it's more your overall state. So how happy are you in your life? That could be your affective states or emotional states. What we know is that environmental enrichments impact emotions. So for instance, fear, we can see reduced fear in chickens when they're housed in complex environments. But we also know that there is some improved learning ability for birds that are housed with complex environments. But that really is all we know in terms of measuring affective states. So there's not a lot of research there yet. And that's mostly because there's not a lot of methods, and definitely not non-invasive methods to measure affective states. So how do you measure affective states? So here comes the theoretical part, so please bear with me. I'll try to explain these cognitive bias tests. They are based on human psychology and have now been adapted to chickens, and we've even done it with fish, so you can really apply to any species if you just think this. If you think about how. So we're going to talk about two cognitive bias tests, and I'll explain why. Affective states, so how you feel in the long term, will impact how you make decisions. This is true for humans, but it's also true for other animals. So if you feel bad, you'll be more pessimistic, more negative in a situation that's not per se positive or negative. If you feel good, you'll be more optimistic, more positive about that situation that's maybe not clearly positive or negative. So how does that work? First, we have emotional responses to anything around us. So any stimulus, you get a free breakfast, it makes you happy. The rain, it could make you happy. But maybe you have to bike home today, so it makes you sad. So all these types of stimuli will elicit short-term emotions. And these emotions can be positive, negative, or anywhere in between. All these emotions in your life, in your day, in your week, in your month, will impact how you feel in the long term, so your affective state. So affective state is not really associated with a specific stimulus. It's not that that breakfast is going to make your life a happier life. It's just an accumulation of all those experiences that will impact how you feel in the long term. And again, these things can range somewhere between positive or negative or neutral. So how you feel will impact how you process information. So people that feel better will be better at information processing, will be better at learning, and it will impact your decisions. And we can measure these decisions in cognitive bias tests. And there's a range of tests out there. Today, I'm going to talk about judgment bias testing and attention bias testing. In these tests, we look at how, in our case, chickens, but it works with other species too, and humans, as I said, we look at how they respond to an ambiguous situation. So I'm going to give another example for humans on judgment bias just to make the concept a little clearer. So I'm from the Netherlands. This is a Dutch meal, is a croquette. And most of you, if not all of you, have never heard of this before. So this is ambiguous. You don't know what this is, right? So I'm offering you a free croquette sandwich today. If you're in a positive affective state, you may think, oh, nice, a free meal must taste good if it's a Dutch delicacy. It looks good, it looks hot or whatever. So if you're in a positive affective state in this ambiguous situation, you may be like, oh, this is great, this looks good. But if you're in a negative affective state, this ambiguous situation may be more negative, you may be more pessimistic about this free lunch you're getting. It looks a little unhealthy, it's deep fried, you don't really like trying new things, it may not even taste good, and then you have to finish it. So how you feel will impact how you respond to something that's not per se positive or negative. And it's the same for chickens, but just not a croquette sandwich is what they're being offered. So in chickens, we can sort of infer their level of optimism or pessimism based on how they respond in the judgment bias test. So a judgment bias is the bias in assessment of ambiguous stimuli, so that croquette sandwich could be good, it could be bad, it's ambiguous. And we are presenting chickens not with those sandwiches, but with some gray bowls that are shown in the middle. But before we can test their response to those gray bowls, we first have to train them. And I can tell you, training a broiler chicken in this test is very time consuming. It's doable, but it's hard. So what we first do is train them to understand that in this case, a black bowl on our left with mealworms is a reward cue or a positive cue. So we're training them, if you see the black bowl on our left, there's going to be a reward there. So that's about 3 weeks of work right there. Then once they understand that the black ball is a positive cue, we start introducing the negative or the neutral cue. So opposite color, it's white, in the opposite location of the arena. And they're going to have to learn that whenever they see the white ball, there's nothing there. There's no rewards, there's no punishment either, but it's just neutral or negative. And once they are able to discriminate between those two balls, we test them. So that's where the judgment bias test really comes in. So we present those intermediate balls, and intermediates in terms of color, so they're grayscale, and intermediate in terms of location. So they're in between the two cues that they are trained on, and we just present one of them at a time. So what we measure here is really how much or to what extent do they expect a reward, so a bunch of mealworms, to be in those intermediate cues or intermediate bowls. So as I said, we had to train these birds. First, habituate them to the arena, making sure they're not afraid. Then train them on the two cues that were reinforced. So the black cue in this example being with mealworms, and the white cue being the neutral or negative cue. So that takes about 6 weeks, if not longer. Then you move on to the actual test. So that's when you test them to see what they expect when you present them with a cue that they've never seen before. So those grayscales, they've never seen those, and they're placed in between those two reinforced cues. So how do they respond to that? And what we measure is the latency to approach. So we measure how long it takes for them to go up to that bowl to inspect it. So I have a little sped up video here of part of the training, and you'll see why it takes so long, because we also had to train these chickens to walk to the back of the arena. So it was really, starting from the beginnings. So you see the black cue in the sort of the bottom left of the video. So there's a black piece of paper and then the black bowl, and we had to train the birds to walk up to the bowl. And you can see this bird is doing quite well, but sort of loses it towards the end. All right, so what do we expect? If chickens are in a negative affective state, so they are unhappy, between quotations, we expect them to be pessimistic in this test. So they're pessimistic that those gray bowls are going to contain some mealworms. So what do we see in the test? We see them slowly approaching the bowl or not even approaching them at all. And then in the opposite case, if chickens are in a positive affective state, so happy, we expect these birds to be more optimistic that there's going to be some mealworms in those intermediate bowls and approach them more quickly. So here's another sped up video of one of the tests. So the birds are exposed to all of these cues separately and randomized, but here I just sort of pasted it in order so that you can see the latency to approach. So mostly focus on how quickly the bird approaches the cues. And it is sped up. So I think this bird really nicely illustrated the sort of the speed, although when walking towards the middle cue, it was a little slower than towards the near negative cue. But you can clearly see the bird knows the reward when it sees the black bowl, goes up to that relatively quickly, and then slows down as the cues are sort of moved away from the reward location and color. Then moving on to our second cognitive bias test, which is the attention bias test. An attention bias is the tendency to pay attention to something negative rather than other stimuli in your environment. So what's good about this test is you don't have to train your chickens, you can just test them. So it's much more time efficient. In this test, we present them with a negative cue, which is in our case, an alarm call that was recorded from a chicken. And I think people at Zoom maybe, or that are here virtually can maybe not hear it, but people in the room maybe can. So this is an alarm call of a chicken warning other chickens that there is a ground predator in the area. So our chickens in the experimental setup probably have never heard that before. So it's sort of ambiguous or towards the negative end if they hear this call. So what we are looking at in this test is whether the chickens focus more on that alarm call or focus more on the feed that is presented to them. So you can see in the picture that they have a familiar feeder, There's chicken feed, but also oats and mealworms in there. We really try to make it attractive for them. So the more vigilant these birds are, the more anxious they are, because they focus on the negative rather than on the positive. So yeah, we present about the two stimuli simultaneously and then see how long it takes for these birds. Oh, there it is again. And then we measure how long it takes for them to start eating. So how long are they focusing on this threat before they're comfortable enough to start eating? And I think anybody who knows broiler chickens knows that they like to eat. So in this attention bias test, we expect birds in a negative affective state, so unhappy chickens, to be more anxious. They focus more on the threat than on the feed, meaning that we'll see a longer latency for them to start eating. For birds in a positive affective state, they are probably a little more calm in this test environment and will not spend so much time focusing on the threats and will start eating sooner. So again, we measure latency to start eating. So here's another sped up video. We initially performed this test with individual birds, but we saw a very limited response. So we've been applying a group approach, or 3 birds at a time, and it's been very successful. So that weird sound is the alarm call. And I think you can see here that these birds were pretty quickly directing their attention towards the feed rather than focusing on the alarm call. And if you look at the beginning, and it's really short because it's so sped up, you'll see that they show some vigilance. So you hear the alarm call and like their head goes up, they freeze, they're like, what's going on? But then really quickly they'll start focusing on other things. So I'll just play it one more time. And we actually played it twice, but that's not something to go into today. All right, so just to reiterate, we have a judgment bias test that measures optimism versus pessimism, a short latency of response. So if they walk up to the cues quickly, that means they're optimistic, and that means they're in a more positive affective state. If we look at the attention bias test, we measure levels of anxiety, so another affective state, where a short latency means the birds are more calm rather than anxious. So these tests are really the first non-invasive measures of affective state in broiler chickens. So I'm pretty excited that we had some good research results that I'll share with you now. So the first study I'm going to share with you focus on providing environmental enrichments under 2 different stocking densities. So we really wanted to create some contrast. The objective was to look at the impact of stocking density and complexity on broiler chicken affective states. And here we only used a fast-growing strain. So we had a 2x2 factorial, meaning there was 2 complexity treatments and 2 stocking density treatments. And in our high complexity or in our enriched environments, we really try to give them the best situation possible, or at least from our perspective. And that meant functional sections. So as Dr. Bobek was saying, a play area, but also a feeding area, a resting area, and a comfort area. And I'll show some pictures in the next slides. And then the low complexity treatment was the control. So that's more similar to industry standards, although it was in pen. So it's, yeah. Then we had a low stocking density, which was about half of the maximum stocking density in a commercial setting. And our high density was about the commercial stocking density. So here are some pictures of the pens. So on your left, you'll see the complex environments, and I have an illustration of that too. So you see those functional spaces. So the idea was birds can make choices. If they're hungry, they can go to the feeding area. If they want to dust bait, they can go to the forage area or the comfort area. If they're tired, they can rest in the resting area. So we really try to give them a lot of choice. And then if you compare that to the control treatment, where feed and water was everywhere and there were no really other enrichments present. We also included some temporary enrichments. And the idea was to increase novelty, keep these items novel. We included those laser lights, but we did it manually, or I have to say the students did it manually. We provided oats in feeder balls. We provided lettuce and later on cabbage. We had some of those colored balls. And then the hay balls that you see. Yeah, I don't know, the hay balls that you see here and string enrichments. So we rotated them every 3 days to make sure that they were, or hoping that they kept a lot of interest in those things. All right, so moving on to the results. Judgment bias test, I'll give you a second to look at this graph. So on the vertical axis, we have the latency to approach. So how long did it take them to walk up to those queues? And keep in mind, if the bars are low, so if the latency is short, that means they were very optimistic. They walked up there fast because they were optimistic to receive a reward. The positive on the horizontal axis, you see the different queue types. So we had those reinforced queues, the positive and the neutral. And we're most interested in those ambiguous queues, the near positive, middle, and near neutral, because those were the ones that were new. So first, the high complexity or complexity treatment, we didn't see any interactions with stocking density. We see that there was a tendency for a difference for the positive queue. So this already meant that the birds in the high complexity pens were maybe a little more motivated to get this reward. So they walked up to the rewards queue much or somewhat more quickly than the birds from the low complexity pens. But what is most interesting is the difference for the near neutral queue, where we see that this queue they've never seen before. The birds in the high complexity pens were more optimistic to receive a reward there. So because they walked up more quickly. And overall, so if you ignore queue type, we see that the high complexity birds were more quickly to approach any of the queues compared to the low complexity birds. If we look at the effect of stocking density, we didn't see a difference. So this also tells us that, in this case, the commercial stocking density did not have a negative impact on their effective state. But I do have to highlight, and I don't know if you've already seen it or not, we could only manage in this experiment to get 9 birds trained out of the 36 that we were training. So the training for the judgment bias test was really hard. And we are or have modified the approach a little, and I'll show that in the next experiment that I'm presenting. Because, yeah, the broiler chickens were not very eager to walk, even though they were not lame. We did look at lameness, but yeah, it was just hard to train them. And with fast-growing broiler chickens, you only have that 6 to 7 week window, and we just couldn't make that work for most of them. So that is a big downside to this test. So what we see here is that fast-growing broilers in the complex environment seem to be more optimistic, so in a more positive effective state than the fast-growing broilers in the low complexity environment. So we did see a difference there, but we didn't see a difference in the stocking density treatments, which could also be a good thing. Then looking at the results of the attention bias test. So here we looked at anxiousness, and a short latency means birds were not very anxious. They were quite calm. So low bars means calm, positive effective state. High bars mean more anxious and a more negative effective state. So again, we see an effect of complexity, but not of stocking density. So we see that the birds in the high complexity pens were more calm, showing a shorter latency to start feeding in the attention bias test than the birds in the low complexity pens. And keep in mind here, we didn't have to train the birds, so much easier test to perform. And no effect of stocking density. Doesn't like me being here. Yeah, so we see the birds feeding faster when they're in the high complexity treatment. And yeah, okay, I said this. So what we can infer from this result is that fast-growing broilers in complex environments were less anxious or more calm than the birds in the more simple environments. And again, stocking density did not impact the outcome. So in this study, we saw that complexity impacted effective state. We saw that the birds from the complex enriched pens had a more positive effective state. They were more optimistic in the judgment bias test and less anxious in the attention bias test. If we look at the effect of stocking density, we didn't see an effect. So high density or low density did not make a difference in terms of effective state here, which is promising because this tells us that maybe a high stocking density in a commercial environment is maybe also not detrimental if the conditions are similar as what we've tested them in. So what we've learned from this study, and I just want to play this while I talk because they love their cabbage. We learned that effective states improved in complex environments compared to the barren environments. Then stocking density had no impact in our study. And the judgment bias test is a really hard test to perform because training broiler chickens is difficult. So that's also why in the next experiment that I'm showing you, we did a different approach and it was more successful, spoiler. All right, so the second and last part of the research that I want to talk to you today is where we looked at the effect of environmental enrichments for 2 genetic strains. So here we had a 2x2 factorial again, meaning 2 strains and 2 stocking density, environmental enrichment treatments. We used the Ross 708 birds and Hubbard Redbro. So we have a fast growing strain and a slow growing strain. And we had housed them at 2 complexities, so low complexity and high complexity, very similar as the previous trial. So lots of enrichments that were there permanently, and then some enrichments that were rotated every few days. And the Zoom thing is hiding part of what's on this slide, but it is very important. So these birds were all kept at low stocking density. So they were all at about a 21 kilo per square meter stocking density. So that's quite important to take into account. This was not a commercial stocking density. So we changed the judgment bias test. First of all, we didn't even attempt it with the fast growers because we were going to run out of time. So we only tested it for slow growing broilers. And we tested the birds in pairs so that the birds could learn from each other, hopefully, rather than having a bird in there alone. And it was quite successful. So I want to play this. So here you see part of the training. So one bird really approached the reward queue quite quickly. You also see a downside of testing them in pairs is that the other bird is trying to reach the bowl and look at what's there, but one bird's in the way of the other. But still, I think it worked quite well. So we did the habituation and training and testing again. Now habituation was successful. Well, it was successful in the other one too. Training was much more successful here. So we were able to successfully train 22 out of 24 birds instead of 9 out of 36. So we could test all those 22 birds instead of just 9. All right, so let's look at the effect of complexity. Keep in mind, only slow-growing broilers in this judgment bias test. So again, the cues on the bottom, the latency to approach on the y-axis, and short latencies equal optimism. Here we have a very interesting and very unexpected effect if we compare it to what we just saw with the fast-growing broilers, because what we see with the middle cue is that the birds from the low complexity pen, so without enrichments, were much more optimistic to receive a reward in the judgment bias test than the birds in the high complexity treatment. So opposite results. So that was fun. So the birds in the high complexity pens were slower, so more pessimistic in their approach and overall. So here it seems that slow growing broilers in high complexity pens were actually a little more pessimistic than the birds in the low complexity pen. So here environmental enrichment didn't seem to improve their effective states. Then we also did the attention bias test with these birds. So here we did include the fast growers and the slow growers. We looked at the latency to feed, but we also looked at how much time of the test they spent vigilant. So vigilant behavior indicates anxiety because they are like alerts, thinking they may be attacked. So vigilance is a negative behavior that we focused on in this case. So first, the effect of genetic strain. So we have our fast growers versus our slow growers, and then our latency to start feeding. So a low latency or a short bar means a calm bird. Here we see that our fast-growing broilers showed a longer latency to feed compared to the slow-growing birds, meaning that they were more anxious in that test than the slow-growing birds. And if we look at the time these birds spend being vigilant in the test, you can see that for both treatments it was quite high. So both were around 80% of the time being vigilant, so they were quite anxious regardless of strain. But we do see that the fast-growing birds were more anxious in their response than the slow-growing birds because they were spending more time being vigilant. So from these results, we can say that fast-growing broilers were more anxious, so in a more negative affective state than slow-growing broilers, regardless of complexity treatments. If we then look at the complexity treatments, again, no interactions in this case, we did not see a difference in latency. So again, a very different result from the fast growers alone, where we did see a difference in latency to start feeding. And we did see a tendency for the high complexity birds to be a little more anxious, show a little more vigilance in the test, but it was only a small difference. So what we can say here is that environmental complexity or environmental enrichments did not improve affective states or did not improve affective states. That's where my emphasis should be. So to summarize, we see that fast-growing broilers were in a more negative affective state because they were more vigilant and showed a longer latency to eat. So maybe our fast-growing broilers are experiencing more of this, while our slow-growing broilers are experiencing more of this. If we then look at the effect of complexity in this study, and keep in mind, stocking densities were low, we don't see an effect on their behavior, so we didn't really see a difference in affective states. If we look at only the slow growers in the complex or the more simple environments, we saw that the slow growing birds in the complex environments were actually in a little more negative affective states than slow growing broilers in the simple environment. So very unexpected, especially if you look at all the other results, like the benefits in terms of behavior, of complexity, the benefits on health outcomes, at least for fast growing broilers. We really see the opposite response in this experiment. So in this case, the birds in the simple environment were happier than the birds in the complex environment, but only slow-growing birds. So we've learned from this study that the fast growers were in a more negative affective state, that slow growers were more pessimistic, so in a more negative affective state in complex environments compared to simple environments. And overall, that providing environmental enrichments can depend, the benefits of that can depend on which genetic strain you're using and possibly also other conditions. So that's an important outcome, I think. So I have one slide of some future research directions, which I think we all should take. One is looking at how much of complexity or how many enrichments do you really need to provide these birds to see a benefit. We've, in our lab, tested a lot of very complex versus no complexity environments, but how much do birds really need to see a benefit in terms of behavior, health, and affective states? Do they need these highly complex environments, or is one or two enrichments enough? Based on the results, it's key, or it shows that genetic strain can have a big impact on test outcomes. So we really need to know if we're gonna go towards a more enriched environment in the industry, if these approaches should be the same for all genetic strains, or if we have to adjust it depending on what genetic strain we're using. And what we're interested in, and what we really don't know yet as a research community, I think, is the plasticity of affective state. So if a bird is in a negative affective state, can we change that? Give them enrichments, does that change their affective state? How long does it take? If they are in a positive affective state, are they in their positive affective state throughout their lives, or is it very variable depending on their life stage, the conditions? So we really don't know yet how flexible these feelings or long-term emotional states are. So we really need to do a lot more, I think, to find that out. If you want to learn more about environmental enrichments for poultry, so not just broiler chickens, our Poultry Science Association Symposium Proceedings paper was just accepted in Poultry Science. So it's a very comprehensive review of some of the benefits of environmental enrichments and what it does to health, behavior, and some future research direction. So yeah, very excited to have that paper published soon. So I'd recommend all to read it. And I'd like to thank the students, of course, for all their work, because it's mostly their work with the hours of training. We'd like to thank you for your attention and the funders for providing support for this research. So thank you.
All right, I think that I could take up the entire question session with my questions, but I'll start. So you mentioned that the judgment bias and attention bias tests are the first non-invasive measures of affective state. What are the invasive measures? Are you talking about tonic immobility or what?
I'm thinking like quantifying neurotransmitters, for instance. Like we know dopamine, serotonin are associated with how we feel, how animals feel. But yeah, you do have to at least collect blood. Then the association between measures in the blood and measures in the brain are, as far as I know, not as well understood. So maybe you have to take a brain sample or something. So it's really hard to know what anyone's feeling, what humans are feeling too. But even harder to know what animals are feeling. So I'm thinking more of this psychological or even
behavioral.
Yeah. So.
And I'm sorry, this one's burning too. So comparing the slow growing and fast growing broilers for the latency to feed, you mentioned that, in the anxiousness test, the fast growing were more anxious. Is that the motivation to eat, or is that related to anxiousness? Because I've seen work with dairy cattle where they just are more neurotic if they're hungry. Can anxiousness be separated from hunger?
That is a good point, especially with broiler chickens and especially fast-growing broiler chickens, because they are so motivated to eat. But what we expected, or theorized at least, is that fast-growing broilers seem to be more motivated to eat just because of their genetic selection. So we would expect the opposite response, where fast growers may ignore the threats and start eating just because it's there and they like eating. So we would expect the slow growing broilers to have a longer latency, but we saw the opposite. So could be related. Also, we didn't fast the birds beforehand, so we haven't standardized their feeding motivation. But still, yeah, seeing differences in those genetic strains and then within the fast-growing strain between environmental complexity treatment suggests it's more due to treatment than hunger.
Questions? Right here?
Thank you. Both of your tests require the birds to stand and walk. So what did you look at in terms of lameness?
Yeah, that is a good point. And I didn't go into it that much, but we did evaluate their lameness before the test and after the test. And we saw that one, lameness was not associated with test responses. And we also, in the second experiment, especially because we had the genetic strain differences, we focused on selecting birds with a low gait score. So we didn't include any birds that were physically lame or like clinically lame. So we tried to make sure that lameness was not part of the equation here. But yeah, that is an inherent difference between genetic strains. That's true.
Thank you. Anyone else in the audience? We've got a couple of virtual questions here. So, Ruth Newberry, can you say that the slower growing birds were more pessimistic or simply less aroused in the test scenario? Good one.
Yeah. Let me think. So that would be in the judgment bias test where we compared enrichment. We're really not sure why there was such a big difference, and then also in the opposite direction of our expectations. So it could definitely be that maybe the test itself was just not as exciting to them as it would be to the birds that would come from a more barren environment. But then we would have seen something similar maybe in the fast growing broilers in the first experiment, which we didn't see. So we think maybe the conditions, especially with the low stocking density, could have played a role, because stocking density was so low in both of the treatments, regardless of enrichments, that maybe having such a low stocking density was enough for the barren house birds to have a good effective state. But then, yeah, that doesn't explain why it was worsened in the others. So yeah, we really don't have a good theory yet why it was so different. So if anyone has any thoughts about that, I would be happy to discuss it.
Bet Ruth does.
Oh, she does? Yeah, maybe. Yeah, well,
Do we
got
have,
to me.
well, one more question from the audience and then we're going to go to break.
Very, very nice talk. You mentioned complexity of the environment is so important, and you have to be careful how complex you make it. Have you ever tried to rank the objects you used for complexity to see which ones might be, the best to try first, and then what's next, and so forth?
Oh, that's a good point, because no, the short answer is no. One thing is looking at their behaviors in the home pen to see which ones do they use most, or where do you see most birds. We haven't looked into that yet, at least, but that's a very good point. So what do broiler chickens value more? Do they like a platform over a hay bale if you give them that choice? And those things, I think we don't know yet. So that is a very good point, and we do have to figure that out.
All right, let's thank our speaker once more. All right, so now we will go have about a 15-minute break, about 13 minutes, 12 minutes, and we'll come back at the top of the hour. Thank you.